look at nature and see how nature actually uses only what it needs. And sometimes when I speak to school children or even housewives or across different layers, including IIT Madras sometimes, I say that the tree itself is probably one of the best examples of how nature has designed it for water management. Even in the rainy season, the roots take only just what the tree needs and leaves behind the rest to be taken whenever it is required. So there are these sorts of examples. I don't want to take too much time of this group here that make people think. And many years back, I showed it once on television where I got them to demonstrate how we need actually just about 5 ml to wet our hands. And at present, we use about 100 to 250 ml when we open the tap. And this wetting the hands is the first step towards washing the hands. Afterwards, you apply soap and rinse it off and things like that. So the wetting of the hands is only to apply soap. Really speaking, what we need is just about 5 ml. But by habit or by the technology of our own respective restrooms or wash basins, wherever we are, at present, we tend to consume 30 to 40 times more. And that itself is what I tell my young students, the young students at IIT Madras or wherever, or an university, or that as people of science and technology, our role is to bring this 150 ml towards 5 ml. By combination of technology, the combination of behavior, combination of understanding needs, understanding risks of overconsumption and things like that. So I think this is what I enjoy doing, and I do it at the industrial level and also at the personal level, at the social level. And yeah, I think that's what I thought I could share with the group today.
Here, the rainwater harvesting is taken as stocking the water. And if this stocking is all right, then what is wrong with dam? Dam is again a bigger tank. And if the dams are non-green, so are the underground tanks. And what is the irrigation area or vegetation area that you are covering? Also, that will help me to understand the volume used versus vegetation area irrigated. I just want you to point out one thing. Rainwater harvesting is not rainwater stocking. Because underground tank is a miniature dam at my plot or your plot or whatever industrial site.
Yes.
Of course, the fortunate part is with roof water harvesting, the sedimentation inflow is not there as it is in case of a dam. Yeah. But this is a wonderful study, and it opens a lot more areas to look into. Now, IGBC norms of 6 to 8 liters per square meter for lawn sprinkling has not been substantiated. And the kind of subsoil water irrigation that I have done, we could achieve it at 0.9 liter per square meter. So versus 6 or 8 liter, it comes to nearly 70 to 90% of water saving. So how 6 or 8 liter per square meter irrigation consumption is not explained by IGBC. But more importantly here, our guest said that 50 KLD is the STP capacity. And from 45 KLD, they could bring it down to 23 KLD. That means 50 KLD capacity of the STP versus 23 KLD water use. It means the plant capacity is double the size of the water that is being treated. And that can lead to a huge imbalance. Thirdly, he rightly said that from sprinkler, they have brought it down to this drip irrigation and all that. But WHO does not permit sprinkler for treated water. Leave aside the capacity and volume and evaporation losses and all that. But these are various parameters, and if you have 9129 kiloliter per annum from the tube well, then the depth and pumping of that volume and energy involved should also be accounted for. Even the depth of the pond is doubled from 1.4 to something like 2.56 or something. Now that bottom debris is the most dynamic part of the pond vertical column. Now this whole thing is in under construction and all that. So 2-3 years after the completion of the pond, what is the state of water? That will be interesting to know. And the shore pitching that you have done is like mummified lungs and kidneys of the water body. The rainwater tapering down into the pond and all that, and subsoil water emerging into the pond through the shore. These are all very intricate, complex natural machineries we are still understanding as a species. But rather than KLD and MLD and all that, if we go into some hydrology of that, it will make a very interesting observation. I have said this earlier and I'll repeat, but my point of addition here is something more than this. 1 gram of soil has a microbial DNA, if uncoiled, extends up to 1,580 kilometers of DNA length. Now, when we cover it up with concrete, very recently, I came across a finding from a New York student of geology, geohydrology, working on Colorado. Sand along the flow of the river traveled 1,200 kilometers, taking 8,500 years. That is where the sand granule is formed. Now that sand grain accumulates a lot of soil and clay and microbes and organics all along its journey. And with 1 bucket of excavator, we take out tons of sand and just plaster it. We'll have to see, because net zero is a highly complex, or rather next to impossible expression. I don't know how frequently or rather loosely it is used in current practices. It's a very disturbing to me, at least. But sand formation, we do not have a design. If we run out of the sand, there is no way we can manufacture it because we have no design. And it's a natural process. But as long as possible, as Dr. Hari rightly mentioned, please use as less cement and sand as possible. You can put the stones and all right, that's fine. But that stone should be available to the entire system beneath the stones and water currents. Quarry dust used as a sand replacement is acceptable to the 50% only. Rest 50% should be pure sand. But more than that, my bigger objection to quarry dust is, quarry dust should go through methylene blue test before being accepted in construction. Now, methylene blue test, I have discussed this with very senior structural engineers who are 5-10 years senior to me in age. Methylene blue test of sand is not heard. Methylene blue test for the quarry dust. Thank you, sir.
Restoration of lake shores typically demands that water and soil meet, and that they're not, that you don't bring in an alien element of concrete and stone and such things there. And that is why traditionally, if you even go to Kadalur south, further into Chengalpattu and panchayats there, you will find that they always did stone pitching. That is, they did not cement it. They let the soil breathe. They let the water connect with soil.
Yeah.
1 square inch of soil or silt in a tank bed connects with, represents 1 trillion microbes. And he says these microbes of water, when they connect with the soil microbes, there is a magnificent dynamic that happens. It's a fascinating story that Ravalji will tell you another day if you connect with him offline. And therefore, now it's maybe too late for you to reconsider this, but at least into future work that you do on such restoration of lakes, please ensure that you let the soil lake banks breathe. That is, do stone pitching. But, this kind of concrete work that governments have taken, I'm sure, this may have been dictated by the panchayat and other people who would have brought in a PWD specification, and therefore it may not have been completely in your control. However, you will have funded it from your CSR, and maybe you have some influence into the future when you're creating such lakes and ponds. 2014-15 at about 60,000 liters, double the current level from what you told us. Is that correct?
No,
You
sir.
were at 45 LPCD at that time. You have now come to 22, 23 LPCD.
We have reduced by 50%, more than 50%.
50%. That's what. So if you are today at 30 KLD, you were at about 60 KLD at that point of time in 2014-15.
45, yeah, approximately. Yes.
Correct. Now, today, if you are at 30 KLD, if you are buying water, let us say at 100 rupees per KLD, let us say commercially you are buying water from a tanker. That would have meant today for you something like, let's say, 9 to 10 lakhs at your current level of consumption. Correct, ma'am? At 30,000, you are at about 12 million liters per year. Let's say 100, therefore 12 lakh rupees you would have saved if you are using all of it from inside. However, there is a small cost for what you're drawing from your bore wells. You're saying that the bore well depth is not too much, etc. So accounting for all that, another 25%, I'm saying you're saving about maybe 9 to 10 lakh rupees in a year.
Yeah.
And yet you're saying that the company has budgeted up to about 40 odd lakhs. How does the economics work for the company?
40 lakhs. See, if you take the CSR activity
Correct.
itself, it's like 25 to 30 lakhs.
Fair enough.
Yeah. So that we cannot account it under this activity.
I got that.
It's giving back to the society.
Fair enough. Fair enough.
Yes.
You see, like, for example, that pond, I have a very good heart in remediating the pollution of ponds and things like that. But my grief is, you do this kind of a great work, and the public, they don't cooperate, the pond is going to be again filled with a lot of stuff. This is my experience. 170 acres man-made reservoir, which is multi-purpose. We remediated the pollution of it. The mosquitoes are gone, the stench is gone, the filariaceous is diminished. So what kind of a monetary value I can put on that one? Sometimes you have to spend some money and you don't see something like a tangible benefit from it in the sense of putting a cost to it. So to me, it is priceless. The intangible benefits that you get from these kinds of projects that you do, rainwater harvesting, elimination of foul stench and all this municipal garbage that the people throw on the road, things like that. And sometimes we have to spend our own little money. Because, I wrote a paper one time just for the heck of it, sitting in my own home here. And I tested myself, suppose all of a sudden, the water pipe is bursted and no water is coming up, and maybe I have to buy some water, how much of water that I need just for myself, an individual per capita. United Nations has said 50 liters per day in the developing countries. I manage with 30 liters a day, including bathing, washing my clothes and things like that. I tested it myself.
Yes.
my home, where the Chicago, there are estimates anywhere ranging from 150 to 250 liters per day, if you include industries, university lot. So one thing I tell you, even when the man's nature is such, when we face disasters, then only we act. Unfortunately, in our field,
Sure.
if we practice all this conservation and everything right from the beginning, it's a problem in India, for example, the spatial and temporal water shortages. Where Ativrishti, Anavrishti. Okay, how do you manage it? K.L. Rao, great hydraulics engineer and water resource specialist in India, suggested the interlinking of rivers. There are problems associated with that. But somewhere, I think in the last count,
Maybe there are 31 linkages or something like that. I'm not current on that aspect.
Right.
But there are engineering solutions that we can find out to avoid some of these discrepancies in water supply and so forth.
You see, only one small suggestion. Since I have been doing very cost-effective rainwater harvesting,
Yes.
and as Rawalji and Dr. Hari very clearly said, less of concrete, less of structure, more connect with the water to the soil. So I have seen concrete rings in your RWH structures, concrete rings. So what I would like to suggest is, even if the ring is required, only one ring at the top, balance can be graded gravel or blue metal, so that the surface area of contact with the soil goes up by 10 to 20 times. And cost-wise, it becomes 1/5 of the cost. And safety-wise also excellent. That is why you know that in all oil terminals, where hollow spaces are not permitted, I always have gone for this graded gravel pits with great effect, actually. Because the connect with the soil is phenomenal.
Definitely.
But remember that if you have volume, let's say you have got say 4 meters and say 1 meter as dia, then you will only be the quantum of water that will seep in if you have a GGP, a graded gravel pit, will come down to probably 0.25 or 0.3 on the quantum of water, right? So you have to see that your sizing of the RWH structures are carefully worked out. The math is very important,
Yes.
Karthik, when you do that.
What happens is, the volume is not important. The surface area connect with the soil is more important.
Correct.
Because soil takes away the water. This is what I want to
Correct.
explain technically to Karthik,
I agree.
both theoretically and practically.
True.
Because surface area of a pit of, let us say, 1 unit in diameter and a 3 meter in height or 3 units in height, the surface area connect with the graded gravel pits is 10 times that of the other one. So more than the volume, the connect with the soil is important, percolation.